Okay, for your information, this class will be recorded for 2 hours. I think without the delay, I would like to start my lesson. Are you ready? Three of you. May I start now? If yes, can you please click on like button? Okay, thank you, Coco, for the response. If you have any problem and you want to have more explanations to improve your understanding, you can actually stop me through the chat box. Otherwise, I will proceed the lessons as usual. Okay, actually, this chapter 1 has four main parts. The first part begins with particle in the atom and atomic radius. We would like to start with the atomic structures. You have learned this before through your SPM level and also IGCSE. After that, when we progress to another part, you will learn more about the energy level. You will actually encounter a different atomic structure. The structure will be more complex and it looks slightly different from what you have learned from the past. So please take note. Atoms actually, as we know, they are the smallest particles to take part in any chemical reaction. So before we continue to other chapters, you need to know their structure well. Here are the important words you need to know about the atom. First is, atoms are mostly empty space. Based on the model I have shown you, this is the model of the carbon atom. The middle part, okay, the center of the atom is nucleus. Outside the nucleus is the empty space. And how do we describe the size of the nucleus? We use the word small. The size of the nucleus is very small. The word very small, same as tiny. It's very tiny. As you can see from this model, the nucleus consists of protons and neutrons. Protons and neutrons are found inside the nucleus. And when you want to tell the location of the proton and neutrons, you may use this phrase inside the nucleus. Other than proton and neutrons, we have another subatomic particles also make up one atom. Another subatomic particles called electrons. Electrons are not inside the nucleus, but around the nucleus. Around the nucleus, same as the word outside the nucleus. It's the same as the word outside the nucleus. So from the first part, we can actually recall that protons and neutrons are inside the nucleus. However, electrons are outside the nucleus. And to be more specific, outside the nucleus, which part of the atom actually contains the electron? Then we will have the word shells. Electron shell. As you process, if you progress to the next part of this chapter, electron shell are also called principal quantum shell, or we can call this as principal energy level. I repeat again slowly. Please hold on. Okay, welcome, Jesse. I want to highlight there are a few words similar as electron shell. We will use this word more frequently in your A level. Other than electron shell, we also call this as principal quantum shell or principal energy level. So electron shell, principal quantum shells, principal energy level actually refer to the same part. As you can see, for the electron cell that is closer to the nucleus, there are only 2 electrons. Further away from the nucleus, the second shell contains 4 electrons because this is the carbon atom. Okay, then how do we group proton, neutron, and electron? Basically, these 3 types of particles, we call them as subatomic particles. When we talk about the subatomic particles, you have to know that these terms refer to protons, neutrons, and electrons. Next part is we will talk about their relative masses and relative charges. Relative masses and relative charges actually are not their actual mass and also actual charges. As you learn, I think, come across with their actual mass and charge in your physics class before, the actual mass and actual charge of proton, neutron, and electron is extremely small. The number is too big, understand? Sorry, it's too small. It's too small. That's why for the ease of communications, we will compare their masses and also the charges among themselves. That's the reason why the number you see here, 1 over 1,836, these are the ratio. Okay, these are the ratio. For example, the relative mass of proton is 1, same as the relative mass of neutron is also 1. When you see the ratio is 1 to 1, this indicates that the mass of the protons is the same as the mass of 1 neutron. I repeat again, when you see the relative mass of proton and neutrons has been written as 1 for both, this tells you that their ratio is 1 to 1. What is the meaning of the ratio 1 to 1? 1 to 1 indicates that the mass of 1 proton equals the mass of 1 neutron. Okay. How about if we compare between 1 proton and 1 electron? As you can see, the ratio is 1 to 1,836. What's the meaning to this ratio? 1 to 1,836. This indicates that 1 electron is very light. How many times 1 electron is lighter than 1 proton? It's about 1,836 times lighter than 1 proton. Okay, so relative mass actually is the ratio. It's not their actual mass or actual charge. Okay, please take note. We compare the mass of the 2 different subatomic particles. If they have the same mass, we put their ratio as 1 to 1. Please take note. Then how about their relative charge? If I put positive 1 and negative 1, what's the meaning of this number? As you know, the number is the same for proton and electron. Both carry 1 unit of charge. I repeat again, proton and electron both carry 1 unit of charge. They carry the same amount of charge. I repeat again, proton and electron carry the same amount of charge. However, the type of the charge they carry are slightly different. As you can see, the side before the number is positive. This indicates that proton carry positive charge. However, electron carry negative charge. But how much charge carried by one proton and also electron from the ratio 1 to 1? Do you see that the ratio is 1 to 1? This tells you that proton and electron carry the same amount of charge, but the type of the charge they carry is not the same. And you will see the number for neutron is 0. When you see the number is 0, this tells you neutron actually carry no charge. What is the word we use to describe the subatomic particles carry no charge? We can use the word neutral. We use the word neutral. So out of these three subatomic particles, neutron are neutral. Or we say that carry no charge. If you want to put the number, you can just put 0. Okay, I think before I move to the next part, you need to know that from this relative mass, you can actually compare their mass. Proton and neutron, they have higher mass compared to electron. That's the reason why the mass of one atom is based on what? Its nucleus. As you know, nucleus contain proton and neutron. That's why we mentioned here, almost all of the mass of one atom is in its nucleus, because the mass of the electron is negligible, means doesn't count, because the mass of the electrons are too light, okay, very light. That's why we don't count the mass of the electron in to measure the mass of one atom. Next part. This electric field experiment is extremely important to conclude that electron carry negative charge, neutron carry no charge. At the same time, proton carry positive charge. But how do we actually prove that they carry different type of the charge? That's the reason why the scientists perform the experiment using an electric field. Okay, yes, electric field. I want to highlight here the questions regarding the electric field actually quite simple. It's either in your paper 1 or paper 2. If this question appear in your paper 2, you will be asked to draw the pathway taken by one of the subatomic particles as it passes through the electric field. Either you can see here, among the three subatomic particles, which particles is diffracted the most? Diffracted. We use the word diffracted means you will see that because the empty space you see is called the electric field. In this electric field, have two different charge of the plate. The first part of the plate here is positive plate. The one opposite to it is the negative plate. As the beam passes through the two oppositely charged plates, you can see electron is diffracted more, and the direction is important. Diffracted toward or away from the positive plate. From your observation, you should be able to tell me that electrons are diffracted toward the positive plate, and you can say away from the negative plate, because it's very clear. If you look at this electron, electrons are diffracted toward the positive plate but away from the negative plate. Okay, let's go through the explanation below first. Proton and electron are discovered by observation of their behaviors in electric field. A bin of subatomic particles. As I mentioned earlier, subatomic particles actually refer to proton, electron, and also neutron. The bins consist of these three subatomic particles, and please highlight the important part here. To perform this experiment, these three types of subatomic particles have to travel at the same velocity. Velocity actually is the speed with the direction. Must travel at the same velocity. If they travel at different velocity, then you cannot compare them. Okay, you cannot compare them. They must travel at the same velocity when they enter an electric field. One plate is positively charged while the other is negatively charged, creating an electric field in the space between them. So the space between the two plates is the electric field. You have to understand this very well. Opposite charges attract and like charges repel. This is the important concept you need to know. Opposite charges attract and like charges repel. Theoretically, as you know, electrons are negatively charged. However, protons are positively charged. If you look at this statement number 4 here, opposite charges attract and like charges repel. You will see that electrons carry negative charge. The negative charge is opposite to the positive plate. So opposite charges attract. However, for the protons carry positive charge. The positive charge actually is attracted to the negative plate. That's why proton is deflected toward the negative plate instead of the positive plate. Next one, number 5. Proton will be deflected away from the positively charged plate and towards the negatively charged plate. You will see there are two keywords here. It's either away from or towards. It's either away from or toward. Proton, obviously, as we know from this observation, proton will be deflected away from the positively charged plate. Why deflected away from the positively charged plate? Because proton itself is positive charge. Like charges repel, remember that. Then why the protons is deflected toward the negative plate? The reason, opposite charges attract. So protons are positively charged. Please take note. When you want to describe the type of the charge, please take note the word charge end in ed. Okay, when you see this positively charged, this phrase is adjective to describe the charge carried by the proton. Please use the correct spelling. ADJ means adjective word. Okay, if you change to CHARGE, it's a noun, different meaning. It carries different meaning. Please take note. Next part, number 6. Electron will be deflected away from the negatively charged plate because negative and negative repel. So electron will be deflected away from the negatively charged plate. However, electron will be deflected toward the positively charged plate. Positive and negative will be attracted. So electron will be deflected toward the positively charged plate. Electrons are negatively charged. Okay, we can conclude that. Number 7, neutron, it passes through straight. Okay, it passes through the electric field, am I right? Without any diffraction. Neutrons are not diffracted by the electric field. They continue to move in a straight line. You will see out of these 3 subatomic particles, neutron moves straight as it passes through the electric field. The reason is neutrons have no charge. Without the charge, diffraction doesn't happen. Number 8. Now, you will actually see that the angle of diffraction between electron and proton. It's very obvious to see that the angle of diffraction of proton is smaller compared to the angle of diffraction of electron. I repeat again. Now we have to compare between electron and proton in terms of their angle of diffraction. You can actually see that proton have a smaller angle of diffraction compared to electron. Then you have to link with their mass. Before that, when we discuss about their relative mass, am I right? Electron is very much lighter compared to proton. As you can see, the ratio is 1/1836 to electron. It's very small in mass. Because the electron has a lower mass, electron will be diffract more compared to proton. As electrons are diffracted more, will give a larger angle of diffraction. That's why electrons are diffracted more strongly than proton. Why electrons are diffracted more strongly than proton? You can say that electrons are much lighter than proton. If you go through my revision guide, if I put the word in brackets, this tells you that the word or the part actually is optional. It's only to enrich your understanding. I repeat again, if you come across with my revision guide, when you see the word has been put in a bracket, the bracket part actually is optional part. Okay? So far, before I move to this number of neutrons, if you have the question to ask me, you are welcome to leave your message in our chat box. Otherwise, I may proceed to the next part, the number of neutrons. May I proceed? If you don't understand any part of these chapters, I welcome you to raise up your questions to ensure you understand at the end of this lesson. No response. This tell you that I can proceed. If yes, can you please press on the like button so then I can proceed to the next part. Okay, then I think I will just proceed. When I finish these numbers of neutrons, I will continue with the worksheet. I will start to discuss the exercises on numbers of neutrons. When you study about this part, you have to know there are 4 terms. Okay, these 4 terms actually, 2 of them refer to the same thing. Out of 4, 2 of the terms refer to the same thing. For example, atomic number or proton number. Atomic number and proton numbers are the same. when you see the term atomic number or proton number, actually this number tell you the number of proton in the nucleus of an atom. Another pair of words is mass number or neutron number. When you see the word mass number or neutron number, actually this number is usually bigger than what? Bigger than the atomic number. And neutron number is the sum. What is the meaning to the word sum? The word sum means this is the total number of proton and neutron. So how do we actually calculate the number of neutrons with the information given about neutron number and proton number? It's easy. We just find the difference between neutron number and the proton number. The difference you calculate is the number of neutrons. Okay, next part. Atom is always neutral. Why we describe atom is neutral? Neutral indicate that atom carry no charge. An atom does not carry charges. Okay? An atom does not carry charges. That's why we use the word neutral to describe atom. Why does an atom is neutral? Here is the important idea here. You need to understand number of protons always equals the number of electrons. Atom has the same number of protons and the number of electrons. I repeat one more time. To every atom, it has the same number of protons and the number of electrons. Please take note. But if the atom is either lose or gain electron, what will be formed? Ions are formed. What is the another word choice to ions? Another word choice to ion is charged atom. If the atom carry charge, we do not call it as atom anymore. We tend to call them as ions. I repeat again. If the atom carry the charge, we do not call them as atom anymore, but we tend to call them as ions. As you can see, the two examples below here, the left side and the right side. I separate them with one separating line here. As you can see here, from the chemical symbol, if the particles is an atom, if you look into the chemical formula, the top part of the chemical formula doesn't carry any charge because atom itself is always neutral. Neutral means does not carry charges. However, when you call the particles as ions, to ions, if you look into the chemical formula here, there is a charge above it. And the charge is one negative charge. Why chlorine atom change into chloride ion? By gaining one electron. To show the gain of electron, please take note. When you want to write the equations, the position of electron is before the arrow to show that chlorine atom gain electron. If atom lose electron, the position of electron will be given after the arrow. Please take note on to show the transfer of electron. If the atom gain electron, the position of the electron you need to write in the equation is away before the arrow. If you want to show the atom to lose the electron, the position of the electron will be returned after the arrow. Please take note. Even though atom may gain or lose electron, but the transfer of electron will never ever change the mass. Why we will say that the mass of an ion is almost the same as the mass of its atom. As you know, the loss or gain of electron and the mass of electron are extremely light, very small. If the atom lose one or two electrons, the mass of the atom will not change too much. That's the reason why the change to the mass of the ions is negligible. So we will say that almost the same as the mass of the atom. Okay. Now, when you answer paper 1, you definitely will encounter the question similar to this. I am not sure how many of you actually know that this is not the cells from the, it's not the cell from the periodic table. I hope that you do not confuse with the way written here, between the way written here and the periodic table. Let me show you the periodic table. Okay, this one box is called a cell. Okay, this is a cell in the periodic table. However, when you look into this periodic table, it also have two numbers. One is above the chemical symbol and another number is below the chemical symbol. But these numbers are not the same as the combination of the number you see here. This is not the same as the cell you see from the periodic table. If you compare, for example, aluminum, the number above it is 27. Below the symbol is 13. If you cross-check with periodic table, aluminum, the number above it is 13, while the number below it is 27.0. So it's totally different. So don't confuse between the cells in the periodic table and also the symbol here. So how do you call this symbol? This symbol is actually called isotopic symbol. I will discuss with you what is isotopic symbol in our 1.2 later on. When you see the word isotopic symbol, right? Please take note. It is not the same as the cells in the periodic table. Okay, different things are. Now you are given the isotopic symbol. The number above the chemical symbol is called nucleon number. Nucleon number is also called what? Mass number. Okay, so the value 27 is the mass number. Then the value of 13 below the chemical symbol is atomic number, or we call this as proton number. For the cells written in the periodic table, okay, the number above it is 13. Then the number below it is 27.0. So what is the meaning of this number 13? It refers to what? It refers to, yes, proton number as well, but be careful with the value 27.0. 27.0 is not the nucleon number or mass number. 27.0 here is AR. What is AR? AR is relative atomic mass. We will need to use relative atomic mass when we come across with the part mole concept later on. Okay, in the following chapters, you will need to use the mole concept to do some calculation to calculate the mass of the reagent in a chemical reaction, or we can use the mole concept to calculate the number of the atom, the number of the molecule present in the chemical reaction. I hope you still remember the calculation you have learned before in your IGCSE or SPM. So please take notes on. Okay, if you know how to read through the isotopic symbol, we can go through the example below. How many proton, neutron, and electron do the following species have? As you can see, the solution has been given below as an example. Number of proton is the proton number, so it's 13. If you want to calculate the number of neutron, you can refer to the formula given here. To calculate the number of neutrons, we use the nucleon number to minus proton number. So if we apply the formula to these questions, 27 is the nucleon number and 13 is the atomic number. Their difference is the number of neutrons. So you can use 27 minus 13 to get 14. So 14 is the number of neutrons. As you can see, the chemical symbol here, you don't see any charge above it on the right side. So this is an atom. If you see the symbol carry no charge, it is a type of atom, not the ion. That's why, what is the meaning of the word atoms? Atom has the same number of proton and electron. Aluminum atom has 13 proton, So it contains 13 electrons as well. The next example is cesium. Cesium here is ion. How do I know this is ion? Because from the chemical symbol here, it carries one positive charge. So this is a type of positively charged ion. Again, the number below the symbol is 55. This is the atomic number. So cesium has 55 protons. To calculate its number of neutrons, we find the difference between its mass number and atomic number. So 133 minus 55, we get 78. As you can see here, this is a type of positive ions. Ions will never have the same amount of proton and electron. To form the positive ions, as you can see the example above, the atom lose electron. Lose how many? You can refer to the charge here. The amount of charge is one positive charge. This tells you cesium lose one electron. How to show it lose one electron? We can calculate it using 55 to minus 1. Then the actual number of electrons carried by cesium ion is only 54 because cesium atom loses one electron to form one cesium ion. Then the next example, oxide, is also a type of ion. As you can see, oxide carry charge as well, two negative charge. Why the oxide carry two negative charge? It's very obvious to see that oxide gain two electrons. Then how do you calculate its number of electrons? As we know, oxide gain two electrons. From 8, it gains another 2. So its overall number of electrons becomes 10. And then to find the number of neutrons found in the oxide ions, you need to find the difference between mass number and the proton number. So 17 minus 8 equals 9. The number of protons you can refer to its atomic number or proton number. So that is the end of the part regarding number of neutrons. Okay, I will not proceed to the periodic pattern of atomic and ionic radiation at this moment. I will pause for a while and moving to the next section to discuss the questions, okay? The questions about the part we have just discussed. I think I will zoom it first. Please get yourself ready with this worksheet. Well, students, I hope you have prepared to go through this worksheet with me together. Now, let us begin with the question 1. The reaction shown occur in gas clouds throughout the universe. What is the atomic structure of H3 positive ions? You need to find the number of proton, neutron, and electron. Okay, let's start now. As you can see from this chemical formula, has 3 indicate that this ion has 3 hydrogen. There are 3 hydrogen atoms. As you know, each hydrogen has how many protons? You can refer to the periodic table here. As you can see, atomic number to hydrogen is 1. So each hydrogen has 1 proton, but this ion contains 3 hydrogen atoms. Am I right? This ion has 3 hydrogen. So the overall number of protons is 3. Okay, the overall number is 3. The explanation I will write below it. There are 3 hydrogen atoms. Hence, there are 3 protons. Okay, now then for this ion, right, the charge carried by this ion is 1 positive. As you know, 3 protons contain how many positive charge? 3 protons contain 3 positive charge. And the overall charge here is only 1 positive charge. So this indicates that this ion contains how many electrons? To get the overall charge as positive 1. Because the overall charge here is positive 1, right? Okay, and this ion has 3 hydrogen. There will be 3 protons. So the initially the charge is positive 3. To get positive 1, these ions contain 2 electrons. So positive 3 minus 2, the overall charge is positive 1, same as the charge given from this chemical symbol. Okay, so the suitable answer here is B. And you know that hydrogen is the only element without neutron. In this universe, hydrogen is the only element without the neutron. Please take note. Okay. So the answer is B. Next one. Which row is correct? The atomic number is the number of is the number of proton, because as you know that proton number is the same as atomic number. Okay. Then the proton number is the number of proton. The mass number is the number of neutron. What is neutron? Neutron is the sum of the number of proton and the number of neutron. Is the sum of the number of proton and the number of neutron. So a suitable answer here is D. Well, we move to the next question. The phosphide, okay. I have to tell you the difference between phosphate and phosphide. This is only to remind to some of you if you're still confused between the two words. Phosphate ions and phosphide ions. Okay, ATE and IDE. What is the difference between phosphate ion and phosphide ion? When you see the word N in ATE, this type of ion is a compound ion. However, if the term N in IDE is a type of simple ion, then what is the difference between the compound ion from a simple ion? Compound ions, it contains more than one element. When you see the word compound ion, am I right? It contains more than one element. If you see the term N in IDE is a type of simple ion, it contains only one element. Now, so what is the another element apart from phosphorus? For this example, there are two elements present in this compound ion. What are the two elements present in this compound ion? If I write its chemical formula, then you are familiar with that. Yes, it's PO4 3 negative. This is the chemical formula to phosphate ions, PO4 3 negative. You will see that this ion contains two elements, phosphorus and oxygen. However, phosphide ions contain only one element, which is phosphorus only. So please get yourself familiar with the differences between compound ion and simple ion. If you see the ion end in ATE, this ion definitely contains the element of oxygen. I repeat slowly again. If the term ends in ATE, the ion definitely contains the element of oxygen. Okay, let's go to the next part. The phosphide ion is used in medicines as a radioactive treatment for some form of cancer. What is the composition of the phosphide ion? The number of protons is 15. And the number of neutrons we should use the mass number minus the proton number. 32 minus 15, then we get the answer 17. And this is ion. The number of proton and electron will not be equal. But this phosphide ion gain how many electrons? You can refer to the charge. When the charge is negative, it means that the atom gain electron. If the charge given here is positive, this tells you the atom loses electron. And this is the three unit of negative charge. So this tells you phosphorus atom gain 3 electron. 15 plus another 3. So the overall number of electrons will be 18. The correct composition of the phosphide ion here should be B. Next one. Which option correctly describe the relative charges and masses of the subatomic particles? If you are a good observer, in my revision guide, I provide you with more accurate reading. I follow the Cambridge textbook. I have provide you with one out of 1,840. Actually, 36. If you check the revision guide, I have given you this number. Instead of 1 out of 1,840, actually, both will be accepted. The difference between these two numbers is the degree of accuracy. 1 out of 1,836, the value is more accurate. Now, we'll go through quickly. Proton carry is 1 unit of charge, and the type of charge carried by proton is +1. Neutron is neutral, so must be 0. Electron carry 1 unit of negative charge. And the relative mass of one electron is 1 out of 1,840. So the correct combination to these questions is C. Question number 5. Which row correctly describe the characteristic of the nucleus and surrounding space? Nucleus, from the start of the discussion, is made out of what? Proton and neutron. Between proton and neutron, only proton carry positive charge. So what is the overall charge of nucleus? Definitely is also positive because neutron carry no charge, proton carry positive charge. So the overall charge of nucleus is positive. So cannot be neutral. Answer A and C are wrong. Okay. Now, the difference between option B and donkey is either nucleus is a large nucleus or small nucleus. As you can see from the revision guide, nucleus is always small. Okay, it's a small nucleus, it's a positively charged nucleus because nucleus contain proton and neutron. The part surrounding space is mainly empty space. So the suitable answer is donkey. Question number 6. S is a particle with 19 electrons and 20 neutrons. Which of the species is S? So you need to know that out of these options, which species contain 20 neutrons? Let's start with option A. The atomic mass, the atomic number of the calcium is 20. If you check from the periodic table. Okay, let me fill in the atomic mass. You can find this from the periodic table. The atomic number. Let me fill in the atomic number to every question here. You can find the proton number or atomic number from the periodic table. Okay, first, let us find their number of neutrons. So for the first option, 40 minus 20 equal to 20. So option A is correct. Option B, 39 minus 19 is also 20. Option C, 38 minus 18 equal to 20 as well. However, the last option gives you different number of neutrons, which is 24. So obviously, Option D is wrong. Okay. And let's continue to find the number of electrons. To find the number of electrons, as you know, the symbol here is 1 positive. It tells you that losers. Okay, when you see the symbol is positive, it means that losers, okay? Losers how many? Losers 1. So 20 minus 1 is 19. Option A is correct, but let's go through for the rest. Again, it's a positive side, mean losers. Losers how many? 1. So 19 minus 1 equal to 18. So option B is wrong. Contain only 18 electrons. No charge. So the number of proton and electron are the same. It's also 18. No charge, same as number of proton. So its number of electron is 21. So out of this option, only option A is correct. Question 7. In which of the following species are the numbers of proton, neutron, and electron all different? Now you have to refer the periodic table again to find its atomic number. But let me fill in the atomic number first, okay? To proceed our discussion, let me fill in the atomic number. You can check from the periodic table. Okay, now we will start with number of proton. Let us go through this faster. 11, 13, 9, 16. Last but not least, repeat again. Atomic number is the number of proton. Number of electron. Number of electron. When you see the positive side, losers 1. So 11 in minus 1, you get 10. No charge, same as number of proton. When you see the charge is negative, indicate gain 1. So 9 plus 1 equal to 10. Again, the side here is negative, gain 2 equal to 18. Okay, you need to find the number of proton, neutron, and electron all different on. Next one, number of neutron. Number of neutron is the difference between the mass number and atomic number. 23 minus 11, then you get 12. The next one, 27 minus 14, sorry, minus 13, you get 14. Next one, 19 minus 9 equals 10. 22 minus 16 equal to 16. So out of this option, only the first option show different number of proton, neutron, and electron. That's why answer is A. Question number 8. The atomic number of an element gives the number of protons in the nucleus, which is also equal to the number of electrons. Which statement explains why atoms are neutral? You need to understand that protons, what is the relative charge of one proton? Its relative charge is positive 1. Am I right? To one proton. To one electron, its relative charge is negative 1. To this question, the element have the same number of proton and electron. So, as you know, when the charge on an electron is equal and opposite, what's mean by this opposite? It means that proton and electron carry opposite charges, and this can cancel out their effect. The positive charge is balanced by the negative charge. Okay, let's say one element have 9 protons, so have 9 positive charge. At the same time, it contains 9 electrons as well. 9 electrons contain 9 negative charge. 9 positive charge and 9 negative charge will cancel out their effect. So the overall charge carried by this atom is 0. So the atom is neutral. Okay, so the suitable explanation for this question is B. The charge on an electron equal and opposite to the charge on a proton. Number 9. Which statement about atomic radius? Okay, this part I haven't discussed yet, so I will move to the next part and come back later. Which is the correct number of subatomic particles for a phosphide ion? I think from the question 10, question 10 to 12, I will reserve it as a homework. You can do it, okay, by yourself. If you encounter the problem, you can please share your question through our WhatsApp group. I will share with you the answer at the end of the lessons. You can also cross-check your answer with the file I will send to you later on, okay, to find out the answer. Now, this question is about the electric field. Which statement is not correct? The proton and electron are diffracted because they are charged particles. Yes, only neutrons are not diffracted. Electron and proton are diffracted because they are charged particles. B. The neutrons are undiffracted as they have no charge. Yes, true. Neutrons are neutral. C. Electron is diffracted more than the proton because it has less mass. Very true. As you know, the relative mass of one electron is only 1 over 1840. So the mass is very small. The particles travel at different speed. This one is wrong. To carry out this electric field experiment, please ensure the beam of proton, electron, and neutrons must travel at same speed. Then you will see the result as above. Okay, instead of difference, the answer is same speed. Okay, remove the word different. Next question. Question 14a. Okay, before I continue this 14a, let's go back to discuss about the atomic radius. Okay, what is atomic radius? Okay, please get yourself ready with the revision guide. Page number 4. Okay, the red dot is the nucleus. So the distance between the nucleus and the outermost shell is the radius. Okay, this show you these are the two atoms. I give example. For example, this one is hydrogen atom. And the next one is also hydrogen atom. Both are hydrogen atom. The center part of the atom is the nucleus. The distance between the nucleus and the outermost shell is the radius. And we call this as atomic radius because the particles is atom. So when we measure the atomic radius, actually is a measure of how big of the atom is. If the atom has a longer atomic radius, the size of the atom is also larger. Okay? So atomic radius, you link to which one? You have to link to the idea of how big of an atom is. In other words, means the size of an atom. Now we are moving to the second part of today's lesson. We want to discuss what are the factors can actually change the size of the atom. You will study the changes of the size of the atom across a period and going down a group. Across a period means if you check the period table, we will study the pattern of the atomic radius from the left side of the period table to the right side of the period table. Okay, that is called a period. As you can see, the diagram I show you here, from sodium to chlorine, is from which period? Sodium to chlorine is from the period 3. Am I right? is from the period 3. I have to tell you that in your AS level exam, you have to be familiar the period table from element hydrogen until the element krypton. The rest of the element will not be assessed. Okay? The rest of the element will not be assessed. You have to get yourself familiar with hydrogen until the krypton. As you can see, across a period, the atomic radius keep decreasing. So between group 1 to group 17, when you check the period table here, the left side of the period table is called group 1, after that group 2. Okay? I am not sure with SPM syllabus, but from previous IGCSE syllabus, right, we normally call the aluminium group as group 3. But for A-level syllabus, we are no longer calling as group 3 element. All the element same as aluminium is called what? Group 13. Okay? Because between group 2 and group 13, there is a block called transition element metals. Okay? This time, we count the transition element metal in instead of group 1, group 2, and then last time we skip the transition element metal and we start the boron as group 3. Okay, but for S level exam, we will not skip the transition element metal anymore. We count them in. So instead of group 3, boron is the group 13 element until helium. Helium will be the group 18. Okay. Now, from group 1 to group 17. But when you see the changes to atomic radius, we do not discuss about the transition element metal. From group 1, group 2, then straight to group 13, 14, 15, 16, and 17. So we do not discuss about the transition element here. Across a period, the atomic radius decreases. When you are asked to describe the pattern of the atomic radius, when you see the command word described in your A-level paper, if they ask you to describe the changes of the atomic radius across a period, then you do not provide any reason. The only answer is you can just mention what I have written here. The atomic radius decreases across a period, that's all. If they say, state the change, describe, then the answer is atomic radius decreases across a period. If you have another command word from the question paper, you see this command word, explain. Or give a reason. Then you need to explain why atomic radius decreases across a period. So let's cross-check with the question here. Sodium is an element in period 3. State the trend. So when you see the command word state the trend, what is the answer across the period? The answer is the atomic radius decreases across a period. Then you will get 1 mark from there. Don't provide the explanation. Okay, so you have to get yourself familiar with the command word listed from the Cambridge exam. Okay, before I continue, so far, may I have the feedback from some of you? Do you understand? Until this point, if yes, can you please press on The like button, is it? So what's so good, huh? Okay, without the delay, I think I will just continue. The atomic radius decreases across the period. Okay, you need to understand when you describe or state the trend is always 1 point. It's only 1 mark. So you must provide another 2 mark for explanation. This question is 1 plus 2, okay? So how to explain that the atomic radius decreases? Okay, I think let's go through together the revision guide here. You need to know a few terms. The first term is nuclear charge. Nuclear charge shielding effect. Before I continue, let me discuss the meaning of the word first. Nuclear charge actually depends on the number of protons. As you can see from the table above, sodium contains 11 protons. 11 protons. Okay? Chlorine consists of 17 protons. So across the group, you will see that the number of protons increases across the period. That's why the first answer you can say is the nuclear charge increases because the number of protons increases. How do you know the nuclear charge increases or decreases? You refer to their number of protons. When you see the number of protons increases, then you can say the nuclear charge increases. Okay? If you observe a trend of the atomic radius to another period of element, if you observe the trend showing you that the number of protons decreases, then the answer is the nuclear charge decreases. I want to highlight here, nuclear charge depends on number of protons. The first idea you can write down. Okay, depends on the number of protons inside the nucleus. Next is the shielding effect. What is the shielding effect? If you study the atomic structure, I think I use another diagram. Okay, as you can see, the diagram on your left side here, the atom consists of 4 electron shell. Am I right? The first electron shell very close to the nucleus, and the shell further away from the nucleus is the shell number 4 here. Am I right? It's the furthest away from the nucleus. Okay, there are 4 electron shell. Then let me tell you the labeling. Okay, if the shell is very far away, is the one furthest away from the nucleus, we call this as outermost electron shell. Okay, so number 4 here is the outermost electron shell. Then how about the first shell to the third electron shell is called what? They are called inner electron shell. Okay, now let's compare these two terms, outermost electron shell and inner electron shell. Both actually contain electron. Electron carry negative charge. Electrons are in the inner electron shell and also the outermost electron shell. So the electron from these two groups actually will repel each other. Okay? How much they repel from each other depends on what? Depends on how many inner electron shells can be found in that particular atom. Okay? If the number of inner electrons are greater, then the repulsive force to the outermost electron shell will be greater. Please take note, okay? So let me continue with my explanation. Let me call this first. I need to remove this one. Okay. The shading effect is okay. This way is better. Inner shell electron repel outer shell electron. decreasing the effect of the positive nuclear charge. Look at here. The shielding effect is inner shell electron will repel outer shell electron. If the inner shell electron repel outer shell electron, then the effect of the nuclear charge will reduce. That is the meaning, called the shielding effect. Okay, let me go through the explanation together. Why the atomic size decreases across a period? Number two, okay, from sodium to chlorine, all these elements are found in period 3. They are in period 3. So all these have 3 electron shell. All the atoms from period 3 has 3 electron shell. Okay. Out of these 3 electron shell, 2 are the inner shell, and the outermost shell is the outer electron shell. Please turn those on. Out of these 3 electron shell, the first 2, or you can say that the electron shell closer to the nucleus are what? Are the inner electron shell. Okay? How you can get the idea? Okay, the first 2 are. And then the last electron shell is the outer electron shell. Electrons are added to the same outer shell. The number of inner electron shell doesn't change. So the shielding effect of inner shell electron does not change. That's the meaning. How do you know the shielding effect will either change or does not change? It depends on, is there any changes to the number of inner electron shell or not? In this case, across the period, all this element has 2 inner electron shell. Okay, even though we know chlorine has more electron than sodium, but electrons are only added to the same outer shell. The shielding effect is not significant. Okay, the nuclear charge increases across the period because the successive member across the period gain 1 more proton, am I right, across the period. That's why the nuclear charge increases. As the nuclear charge increases, can attract the outer shell electron closer to the nucleus. As you know, the nucleus is positively charged, am I right? As the nuclear charge increases, can easily attract the outer shell electron toward the nucleus. So the size of the atom will reduce. Okay? So the answer to this question's explanation is from here. The explanation. You have to mention what happened to the nuclear charge and also the shielding effect. To this question, nuclear charge increases, shielding effect doesn't change. These are the two answers for that question. Okay, the shielding effect of inner shell electron does not change because across the period, electrons are added to the same outer shell, not to the inner shell. Please take note. Next part is we discuss about the atomic radius going down the group. I will take group 1 as the example. As you can see from these pictures, the atomic radius as the element starting with lithium to rubidium, you will see the atomic radius keep increasing. So when you are asked to describe the pattern or the trend of the atomic radius when going down the group, the answer is increases. Why the atomic radius increases down a group? As you can know that lithium is from period 2. What is meant by period 2? 2 electron shell. Has 2 electron shell, okay? Then sodium has 3 electron shell. Potassium from period 4 has 4 electron shell. The last one here, rubidium, is from period 5. Has 5 electron shell. Okay, so from 2 electron shell increase to 5 electron shell. The number of shell increases is true, and the outermost electron shell is further from the nucleus. As you can compare, from 2 electron shell increase to 5 electron shell, am I right? Definitely, the distance between the outermost electron shell and the nucleus is further away to rubidium compared to the lithium. The shielding effect of inner shell electron increases. As you can see, the number of inner electron shell keep increasing, right? Okay, for example, lithium has how many inner shell electron? Has 1. Okay, because overall has only 2 electron shell. So for lithium has 1. Inner shell, 1 outer shell. Rubidium, 4 inner shells with 1 outer shell. Definitely you will see that from 1 inner shell increase to 4 inner shell. Definitely the shielding effect of inner shell electron also increase, will give a greater repulsion to the outer shell electron. So then somebody might ask me, going down the group, the number of proton also increases. Am I right? The nuclear charge also increases. But you need to know that between the nuclear charge and the shielding effect, which one is more important? Which one gives more impact? The idea is the increased shielding effect outweighs the increased nuclear charge. Even though the number of proton increases, but the increase in shielding effect gives more impact than the increase in number of proton. Please take note, okay? When the number of inner shell electron increases, can increase the shielding effect of inner shell electron. And this one is outweigh the increased nuclear charge. The meaning of the word outweigh means give more impact. Okay? Outweigh means give more impact. The outer shell electrons are less likely to be attracted closer to the nucleus by the nuclear charge. Okay, because there is a strong repulsion. The inner shell electron repel the outer shell electron away from the nucleus. Okay, so the distance between the outer shell electron and the nucleus will be much further away. So the nuclear charge, even though increases, but it's less likely to attract them toward the nucleus. That's why the atomic radius increases when going down the group. Next part is ionic radius. Ionic radius is we discuss about what happens if the atom loses or gain electron. As the atoms lose or gain electrons, what are the changes to its size? Understand the size of the ion. As you can see that going across a period, both show a decrease in the ionic radius, but please take note between which group? Group 13 and group 15. Why there's no group 14 here? Because the element from group 14 are normally used to form giant covalent structure instead of forming the ionic compound. I repeat again, elements from group 14, they are rare to lose or gain electron. They prefer to share electron to form the covalent compound, such as what? Carbon. Carbon will share its electron with oxygen to form the carbon dioxide. Carbon dioxide is the covalent compound, not the ionic compound, understand? So we discussed about the ionic radius, we emit out group 14 element because they are rare to form the ionic compound. In this case, they do not form, they are rare to form the ion, okay? Now, look at this between group 13 and group 15 and give your attention to ionic radius. As you can see from the reading here, there is a big change to the ionic radius from 0.053 nanometer to 0.212 nanometer. That's a big jump from group 13 to group 15. Okay, so why this can happen, I will discuss it later. A large increase between aluminum and phosphide ions, okay? However, let's discuss first. From group 1 to group 13, same as from group 15 to group 17, ionic radius decreases. Okay, why? The nuclear charge increases as the number of protons increases. I'm sure you agree with me because sodium has how many protons? Sodium has 11 protons. Okay, sodium has 11 protons, and then chlorine has 17 protons. So as the number of protons increases, nuclear charge increases. So please take note. However, all these elements are from the same period. If they are from the same period, the number of inner shell electrons will be the same. That's why, again, the shielding effect of inner shell electron does not change because all these elements are from the same period. They are from period 3. All the elements from period 3 has how many inner shell electrons? Sorry, it has how many inner shell in total? Has only two inner shell. Understand? Out of three electron shell. Because period 3 element has 3 electron shell. Okay? Now, the increased nuclear charge attracts the outer shell electron closer to the nucleus. Okay? As the nuclear charge increases and the shielding effect doesn't change, the increased nuclear charge can attract the outer shell closer to the nucleus. So the ionic radius decreases. Now, why there is a big jump between aluminum ion and phosphide ions? The reason is, let's write down the electronic configuration of aluminum ions. To aluminum ions, what is the electronic configuration? Will be 2A. The first shell has 2 electrons, the second shell has 8 electrons. Magnesium is also 2A because loses 2 electrons. Aluminum is also 2A. How about the phosphide ions? It gains 3 electrons. To AA. Sulfide to A as well. Chloride 1 negative. It's also 2A. Okay, now you will see that electron in aluminum ion fill up to the second shell. Am I right? Between aluminum ion and phosphide ions, electron fill up to only the second shell. But for the phosphide ions, electron in phosphide ion fill up to where? Up to the third shell. The shielding effect of inner electron in phosphide ion effectively reduce the attraction of nuclear charge on outer electron. Okay, as you know that if the number of inner electron increases, I repeat again, when the number of if the number of inner shell increases, am I right? The shielding effect will increase as well. Okay, so the shielding effect of inner electron in phosphide ion can reduce the attraction of nuclear charge on outer electron. This is reason why the ionic radius increases sharply from 0.053 nanometer to 0.212 nanometer. Okay? Now, if we compare the same element, okay? Compare the same element, atomic radius. I hope today you gain the knowledge. Actually, I welcome the feedback from most of you, or they will be great if everyone can give me the feedback like how well you understand throughout the lesson for my personal improvement. I welcome your feedback. So far, I will appreciate that if you can give me the feedback, whether you understand better or you can tell me your feedback honestly. I don't mind. Okay, for my personal improvement. Okay, okay, look at here first. For the same element, sodium atom, sodium ion. Magnesium atom, magnesium ion. Aluminium atom, aluminium ion. You can see, compare between atom and ion, right? The atomic radius is greater than ionic radius. This indicates what? If the metal atom loses electron to form the ion, the size of the atom will reduce. Why? Why the positively charged ion are always smaller than the atom? Because you need to answer based on what? The ratio of proton to electron. Let me take magnesium as example. Magnesium atom and magnesium ions are from the same element, right? Magnesium. Magnesium atom and ion, okay? If you calculate the ratio of proton to electron, magnesium atom give you 1.0. However, magnesium ions, 12 divided by 10, you get the ratio as 1.2. So if the ratio is greater than 1.2, the nuclear charge will increase. When nuclear charge increase, right, can attract the outer electron shell closer to the nucleus. So the radius of the atom will reduce, understand? Remember that, huh? How do you know the nuclear charge increases? If you want to compare between the atom and ion from the same element, you can find the ratio of proton to electron. Okay, for the positively charged ions, you definitely will always get the ratio bigger than 1.0 because the nuclear charge increases as the atom loses electron to form the positively charged ion. Remember that. Okay. Increases. Next one. How about the non-metal atom? Non-metal atom, right? As they form the ions, you will see the size of the atom increases. Before that, okay, let us take phosphorus as example. Phosphorus atom, the atomic radius is 0.110 nanometer. By gaining electron, increase to 0.212 nanometer. It means that the size of the atom increases after gaining the electron. Why this can happen? If you calculate the ratio of proton to electron, for the phosphorus atom, you will get the ratio as 1.0. However, for phosphide ions, P3 negative ions, 15 over 18, you will get the ratio as 0.8. It's smaller than 1.0. So the effective nuclear charge actually decreases. When the effective nuclear charge decreases, the nuclear charge is less likely to attract the outer shell electron closer to the nucleus. So the ionic radius will increase. I hope I have enlightened you from this part. I think the last part, ionic radius going down a group, is the same as the atomic radius going down the group, same explanation. Okay, you can go through it by yourself. Okay, before I dismiss the lessons, I would like you to complete the worksheet. If you want to submit for marking, you are welcome to do so. I can mark for you. And the end of the lessons, I will also, I think by tomorrow, I will send you the mark scheme of the worksheet. Okay, if you want to submit for marking, you are welcome to do so. If you don't want to submit your worksheet, you can check the answer, okay, from the copy of the mark scheme I will send to you by tomorrow. Okay, from that, I would like to say thank you for your attention and welcome you to join my lesson today. And also, as I mentioned, if I did badly, please let me know so that I have the chance to improve the next lesson. Okay? That's all for me today. Thank you, all of you.
Thank you, teacher. Bye bye.
Thank you.
Thank you, sir. Bye bye.
Thank you. Welcome.